Welcome to qnawire.
Hi, so over here we're given the following situation where we are going to have the experimental data of the concentration of the iron plus ion and the absorbance of the sample measured on the under 511 nanometers light. So in this case, remember that the absorbance is going to be equal to epsilon times the length path times the concentration. Over here, we're not given the value for the length path, but in general, for most of the experimental setups, the length path is going to be equal to 1 centimeter. So if we plot A as the y function equal to epsilon L times C, what we're going to see is that our equation, in this case the value for B should be ideally 0, but we're going to see what happens on the experimental setup. What we can relate is that a linear fit in between absorbance and the concentration is going to give us that the slope, which is m, would be equal to epsilon times L. So, in this case, plotting these values, we're going to get the following diagram. So, over here, as you can see, I wrote down again the values for the concentrations and the absorbances, and I plotted concentration on the x-axis and absorbance on the y-axis, and we did a linear fit. With this, we find that the value for the slope for m should be equal to 111.45. And what are going to be the units for this? Well, the units needs to be remembering that the slope is going to be equal to change of y divided by change of x, and that the change of x is going to have no units at all. The units should be molarity to the minus 1, since we're given the concentrations in molarity. So we're going to write down as molarity to the minus 1. And this is going to be equal to the absorption coefficient and, the molar absorptivity of the complex times the path length that it traveled. So for this reason, we can directly say that the path length, considering that L is equal to 1 centimeter, would be equal to 11,145 molar to the minus 1, centimeter to the minus 1. And with that, it would be all. Thank you very much, and have a good one.